In part 1, we'll have a look at various commands, as well as some other commands that will come along as we move through these. Echo, ls, cp, rm, vi, cat, df, du, t. If you already know in detail what each of these does, you can probably skip ahead to one of the following parts. However, if you don't know what these do, or if you would like a recap, then come and let's have a look. So first here, we're signed in to a server with this IP address, and it nicely gives us the date. It also tells me the user ID, which host I'm on, and I'm currently in my home directory, which is indicated by this little tilde here. Let's start very easy and change into the root directory. Now we have an indication that we're in the root directory. We could jump into the binaries directory. And again, we have an indication of the same. Lots of binaries that are available for us to use. Let's swap back into the home directory. And while we're at using the change directory command, there's a very handy shortcut. If we do cd dash, we will swap back into the last used directory. And we can do this again. Because this happens all the time in QA, where you're working between two different directories of files, it's very handy to have this command available. Let us clear the screen so we can start from scratch and run a command like uname with all the output indicated with -a. So we're on the local machine here again, and we can see that we're probably in the Red Hat area or in CentOS because we see the EL here. And we are using 4 cores, 1, 2, 3, 4. We also get a indication of the time. Let's also run a woo command. So this is myself signed in on this virtual terminal, and I've got a certain time here. Compare it with the current time, and we can see that this is the time that this session or this particular shell session was opened on this IP address. So we've now also seen the date command, very handy. Now many of you might try the time command, but the time command gives a very strange output. It's not actually the time, because the time is included as part of the date. What time does is it gives us, and we can see the date output here, what time does, it gives us the output of how long something has been executing for. In this case, a very, very short time. Now, as we knew that we were on some sort of Red Hat release, we can have a look at this file, which is available on Red Hat and CentOS, and indeed we're on CentOS version 7. So, let's start with something simple. We'll clean the screen and say hello world. Now, that has been used too often. Hello Percona. This works fine, very simple and straightforward. Straight away note that we could also use a single quote. Works just as well. Later on we'll see a bit more detail about the difference between those two. Okay, let's have a look what's in the home directory. Okay, a bunch of directories and a file. How can we make sure that these are directories? Well, we know the different colors, but if we do ls-l, we can see that these are directories, and this is not a directory, this is a file. This file is 48 bytes large. It's owned by the group rule and owned by the user rule. If I do the same on root, notice how I specify the directory here behind the command, we can see a number of directories owned by the group root and owned by the user root. We can also see some links that point from one thing to another. We can also see a file and again the dates and the times of each of those files and directories. So very straightforward. We have the ls command. The -l just simply gives us a long or more detailed output. Compare the two. We can also use dir if we've been used to Windows for too long. And the output is similar, just with a little bit less colorful syntax. Okay, so we have a file here, test5, 48 bytes large, and we want to copy it. For this, in Windows we would do something like copy. In Linux we use cp. Let me see, copy this file to from test5 to test1, and sure enough, there's a copy of our file. So we've used a cp command to copy files. Let us also remove the file. rm, very similar to del in Windows, simply deletes the file. Can we also delete a directory? No, not immediately, because it's a directory, and so we get a bit of a warning. Let's try the same command, and notice how I can press cursor up and cursor down to sort of scroll through all the previous commands. You can also use the history to see what commands you've been entering. So, in this case, we're going to use -r, which means recursive. And there we go, we've deleted the test4 directory. Let us make a new directory, and for this we use the mkdir make directory command. And we'll call this directory test1. Let's clear the screen and see what's there. Okay, so we have a directory, and we're going to move, for which we use the mv command, similar to the move command in Windows. The move command to move test5 to test1. The file is indeed gone, and let us have a look inside test1. Yes, the file is there. Now if we try to copy the directory test1 to test2, so we're going to try and copy this directory, that fails because again it's a directory, so we have to say again recursive, just like we did with the remove command, the rm command. So we copy from test1 to test2, and sure enough that's worked perfectly. Let's have a look inside test2, and our file is there. So we're going to remove these two directories, and all is gone. Now, let's say that we try and delete a file which is not there. T. No such file or directory. In this case we can use the f command, which forces, which is not necessarily a good term here, the removal without any notifications. So we don't get an output, which is handy for inside scripts where we don't want all this information scrolling through the output of our script. And if the file t hadn't been there, would have been there, it would have been deleted. How can we be sure? Well, let's make a file. We're going to make a file test with the vi command, which is another command we're having a look at. And here we see indeed we're creating a new file. Now inside vi, if you've never worked with it, there's something like a command mode and an edit mode. Now we're in the command mode, and we have to press I to go into insert mode, and we're now editing. And we can enter some edit text, press escape, which will get us out of the insert mode, and now we're back in command mode. Here we enter the following command. We start by a colon, which brings us to the bottom here and allows us to enter a specific command. We write the file out, and we're going to quit immediately. Sure enough, the file is there. So in this case we're going to say delete the file tests and don't notify me in any case. And of course the file is gone. Okay, great. Now let us have a look at another command which we've been using here already, the cat command. Cat basically just outputs the contents of a file. There are other ways of doing this, but first we have to create another file. Let us start vi, and notice this time, actually let me clear the screen first. This time I'm not going to enter a file name. So we get a nice banner saying, okay, you're working in Vim, and I'm going to insert mode again by pressing I on the keyboard. We insert our text that we want, we press escape, We're going to write out this file, but notice we're not specifying a file name. It's going to, of course, give an error. It says no file name. So we're going to say, write this out as test. Sure enough, there's the file test, and we can have a look at its contents with cat. Yep, the contents are there. Now let's say I want to redirect the output from cat test, into another file. Okay, so this time we don't see any output. And let's have a look at test2, which is a new file. There it is. And sure enough, the output is there. Now, if we did the same once more, the output or the contents of the test2 file is still exactly the same. That's because this redirection just says recreate this file. It doesn't do anything more than that. Simply, we could run this 100 times, and the output of test2 would still be whatever output was generated by what comes before it. This is in contrast to when we want to append. This command is very similar, or this redirection is very similar to the one used here, but in this case we're going to append to the file. Now we have two outputs, and if we try and run this multiple times, we have a number of times repeated. For this, there's also other commands that we can use. For example, we can t the output of a certain command via a pipe. So basically what the pipe is doing is it's taking the output from this and sending it into this. So it's taking the output from this and sending it into this, into another file at the same time as outputting it. Let me show you how this works. So we've used getTest, this has generated output, and at the same time we've piped this into t command test2. In fact, what has really happened is t is the one who has outputted this particular bit of text. How do I know this? Well, for instance, if we were to run getTest, pipe it to ls, then ls really doesn't do anything with this. It will just stand on its own. So we get a directory output, but we do not get to see the contents of our file. Versus here, let's come back to this command. We're taking the output of this getTest command, sending it into t. T is going to output whatever this command outputs, so it's basically just going to re-output whatever is happening here. And it's going to capture all of the output also in test2. Great, there we go. And if we look at test2, it has captured the output. So in a way, the t command is very alike to the redirection with a single greater than symbol. One difference is that here we have simply redirected all the output into a file, versus here t has outputted the same of the actual command, and it has redirected and it has stored the output into a file. So what we can do now is we can also say test t minus a test2. This is t minus a is append mode, and this is very similar to the double greater than symbol redirection. Let's have a look. So it still outputs, t is still outputting all the information. And let's have a look at test2. Yeah, it has appended the output of this command a second time. So if we were to run it multiple times, and for good measure, we do the same in this way. Notice that this time we're not seeing the output because all of it is redirected, versus here all of it is t'd. And we look at test2, we have the output from all of these commands appended, appended, appended. We'll look more into redirection a bit later on. So with all of this file work, let's say that we want to have a look how much storage we have available on this system. We run df-h, where -h gives us a human readable format. So all of these numbers are in gigabytes and megabytes so that we can understand what we're seeing instead of bytes, and then we have to do all sorts of calculations. So it gives us a percentage of how much space is in use, how much is available, how much is used, how much the total size is of a particular partition. In this case, the home directory is, the root directory is mounted on the file system, or in this case the partition dev sdb2, which is the second partition on the second drive. So let's have a look in which directory we were. Now there's several ways of going about this. If we check the pwd system variable, we can see the current directory, or we can simply say pwd and it will give us the path working directory, the current directory. So in this case we have the directory home rule, and we don't see that there's any particular directory here called home. So by this I know that the home directory is a part of this particular mount. To understand this better, because it's very different from those of you that come from a Windows background, to understand it better is you have to understand that each partition or each disk can be mounted as a subdirectory in Linux. Whereas in Windows you would have the C drive, the D drive, and so on. So for instance, if I swap into SDD, now I am working on this particular drive that has about 3 terabytes available. Let me swap back to where I was, and now I'm back here, even though I'm in the subdirectory of this. I'm in home rule. So mount points are a very important concept within Linux. You can mount any drive or partition as a subdirectory, and thereby, by using that subdirectory, you're using that particular drive or that particular partition. Even if you're working with a particular drive, of course, you would have one full partition within that drive, if there are not multiple partitions available. Okay, so let's have a look at what we have here and make a directory test5. Move our 2 files into test5, and notice how you can specify multiple source files and then one target directory. Jump into that target directory. Let's have a look. Okay, so we have 2 files here. One is 8 byte large, the other is 96 bytes large. And we want to get an idea as to how much space this particular directory is consuming. In this case, we would use a command like this: disk usage, and S is in a summary sort of format, and H means in a human readable format, just like the H that we used in DF. Okay, so this particular directory, indicated by dot, notice that we can use dot to indicate this particular directory that we're in, takes up about 12 kilobytes. We can also do something like simply refer it to a subdirectory. So to recap, we've seen the echo command, which outputs standard text. We've seen the ls command, which gives us directory overview, ls-l, which gives more detail. We've seen the cp command, which copies, with -r for subdirectories. We've seen the rm command, which you can also use with r for subdirectories and with f for force or no warnings. We've seen how we can use vi, and we've seen how we can use cat to get certain files. We can specify subdirs, and notice, by the way, how I can use tab. I type TE and I press tab, and automatically it will get the best possible answer. If I tried something like this, it would resolve up to the point where it doesn't know what to do. If I now enter a dot, and press tab again, now it knows that I'm talking about this particular directory. It's different in Windows. In Windows, if you press tab, it just simply grabs the first possible answer, then the second, then the third. It's a lot more easy this way, believe me. So, in this case, I press TE, tab, TE again, tab, and it has all the possible options. Now let's say that there are multiple files. I press tab, tab, and it will give me all the possible options from this moment forward. For example, to come back to this example, if I press tab, tab, the two possible options are the first one and the second one. So let's have a look at the file. We saw the cat, we saw the df command, which gives us the disk space, we saw the du minus sh. So in this case, my complete home directory takes up about 1.3 gigabytes. We saw the t command, which is very similar to the redirection, but with the t command, it provides, the t will provide whatever output is coming from the original command on the screen as well, while redirection will just redirect it and not do anything else with it. We see the t minus a, which is very similar to the double greater than symbol. We saw things like uname, which gives us information about the system. And that's about all for the first part. I hope you picked up a little bit, and please move on to part 2.